Now we're going to look at reviewing in Unit 2 in your practice workbook. So you're going to be on page 113. For number 1, it says consider the values in the table. Look at this table right here. Does the table represent a function? Explain. Letter B says if you switch the input and output values, would the table represent a function? Explain. So when I look at my table, what I want to see is that everything changes as I go up in my input. It only changes by one value. So just by taking a look at our x's, we see that our x's, the numbers in our x values, don't repeat. So this is, our input is a function because our x values do not repeat. The second part of our question says if you switch the input and the output, so my 2 switches my 4, so all these numbers here move up and they become our input value. So I have 4, 1, 0, 1, and 4. And from here, my 4s I know repeat, my 1s repeat, so I know it's not going to represent a function because the 2s, there's 2 1s right here, and there's 2 4s. Alright, number 2 says the equation C equals 50 plus 35M shows the amount C that Dina paid for her health club membership after M months. We're going to call it months, M. The table shows the amount Judy paid for her health club membership. Which statement is true? Select all that apply. So my input is my number of months. My output is the amount Judy paid. A, Dinah paid her a higher amount to join the health club. B, Judy pays more per month to be a member. C, after 1 month, Judy has paid more than Dinah. Or D, after 4 months, Dinah has paid more than Judy. So this equation here is for Dina, and this table is for Judy. So this problem says Dina paid a higher amount to join the health club. This is how much Judy paid to join. This is how much Dina paid to join. That is definitely not true. So now we're looking for the rate of change, how much it changes per month for Judy. We know that Dina's rate is 35 and her initial value is $50. Judy's initial value is $80. We know that 80 to 105 is $25, so Judy's rate is $25. So we know that's not it. It says after 1 month, Judy has paid more than Dina, so for 1, I'm going to put that 1 in for M and solve. Find that Dina paid $85, so that's not true. So after 4 months, let's see what happens. Oh, I'm sorry guys. After 1 month, Judy pays 105 and Dina only pays 85. So Judy did pay more than Dina. So my answer is C. And I solved for 4 months. I have set up my problem, 50 plus 35 times M, that's my number of months. This time it's 4 months. So I'm going to multiply 50 plus 35. 35 plus 35 gives me 70. 70 plus 70 gives me 140. And 50 plus 140 equals 190. So Dina pays more than Judy because after 4 months, Judy pays 170, 80. So Judy pays 180 in month 4, and Dina pays 190. So she pays more as well. So this answer D is also true. To page 114 on the next page and do number 3. It says which function is linear? Select all that apply. Looking for our x's that are to the first power, so A is good. B has an x to the second power, so that's not good. C has an x to the first power, so C is good. D has an x cubed, that's not good. E has a 5 over my x, so that's not good. And here I have my x to the first power and my x to the first power, so this is good. Let's go to number 4, beside number 3. The table shows a linear function. So there's my input, my x, there's my output, my y. What are the slope and the y-intercept? So in order to find my y-intercept, my x has to be 0, so I'm actually going to have to do some work and solve here. When I go from 1 to 3, I'm adding 2. When I go from 3 to 6, I'm adding 3. Over here, 5 to 11, which gives me 6. So if I do 6 over 3, that's going to give me 2. 6 over 2, and when I divide 6 divided by 2, it gives me 3, so my y equals 3. Then from 11 to 20, we add 9. So I do 9 over 3. That one also gives me 3. So if I divide my 6 by 3, that will give me 2. So 6 divided by 3 gives me 2. So my y-intercept equals 2. Type down below says the graph shows the time and the distance a train is from its destination city as it travels between 2 cities. So here's my graph. The bottom axis, my x-axis, is my number of hours. My y-axis is the number of miles. It says identify the slope and y-intercept and explain what each means in the context of the problem. Then write an equation for the line. Initial value is always the number where the line crosses our y-axis. Our y-intercept equals 400. And we're going to pick a number on our slope. That is 1, and 4 squares over. So that's 1, and we'll pick this one right here. Okay, so I'm going to count up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. So to get from that point to this point, it's up 4 and over 5. Looking at our scale on our graph. So we look here and we went from 200 to 400. So that means we went up 200 miles. If I divide 200 by 5, that gives me my slope. This gives me 200 divided by 2.5. So I looked at my graph down here for my number of hours. I went over 1, 2, and a half. So if I put my point here at half, it's going to be 2.5. That gives me a slope of 80. Equation is going to be 80x over 400. Initial value is 400 and my rate of change is 80 miles per hour. Number 6, right next to 5, says Jordan rode his bike to the park. The graph shows his distance from home on his trip. So here's his graph, here's the time, here's his distance. Use the graph to describe what happened at each part of the trips. We have part A, part B, part C, and part D. Here in point A, Jordan is riding at a constant rate because it's constantly going up. There's no change and it's a straight line, so it's constant. Section B, it's a straight line, so that tells us he's not changing in his distance, it's staying at the same distance. So this probably means he's at the park for an amount of time. And here at C, we see that it's a steeper slope than A. So he's probably riding a lot faster here because we're going from here to here in a shorter amount of time, whereas if we go from here to here, it was a little bit of a longer time. So if it's a shorter amount of time to get from here to here, that probably means he's riding faster and he's riding home because this is his distance from home. So the closer we get here, the closer we get to home. And notice where he stops. He stops pretty close somewhere. And at D, there's a big break right here. And it looks like the slope is a lot less steeper, which means he's going to take a lot more time here. That probably means he hopped off his bike and probably walked home because he ends up here. Remember our distance from home, he ends up here, back at home, but it's just at a slower rate. Maybe his legs are tired. All right, now you're going to go back into Google Classroom and you're going to finish the rest of the review activities that are posted in Google Classroom. I also posted them on this task list for this week, so you can look on there as well.